Okay, so Alex, I want you to pay very good attention to everything I'm going to explain here so that you understand exactly what I want you to do. Okay, so if you follow whatever I'm going to explain, you should be able to understand and do exactly what I'm going to do here. All right. So the first thing I want you to do is to ensure that you've installed all of these packages. So these are everything I've asked you to install before now. One of them is for you to download Python. So downloading Python is simply go to their website at python.org and download it, and then once you've downloaded it, you install it in your system. Now, once you've installed your system, you should be able to install, once you've installed Python in your system, you should be able to install other packages like NumPy, Panda, and Notebook, which are the three important things we are going to use. So this NumPy is a Python package, while Panda is also a Python package, while this Jupyter Notebook is a desktop application. So if you've installed all of them, you should already be able to see that. So once you've installed all these things, or the way to install these things is to just open your terminal. To open your terminal is not hard. Just go and type like CMD. If you type CMD on your system, like short form for command prompt, okay. So if you type it, you should be able to see command prompt showing like this. You should be able to see command prompt showing. So hold on, let me. So once command prompt is showing the way it's showing right now, you can simply type whatever I want to do. Hold on, please. Let me cancel this thing. I don't want this drawing to be showing. Okay. Okay. So once you open your command prompt, remember I said just um search, go to this your search and type CMD. When you type CMD and enter, you can open it here, or you just press enter and it should open. So the way you install these packages is just like this. For this numpy, you can simply type pip install numpy. Okay. So once you do that and enter, it should be able to install numpy package for you. Okay. So I already have all of these things, so I don't want that. I've cancelled it because my numpy is already installed. Okay. So you can also install, after installing numpy, do the same thing for panda. If you look at my own command prompt right there, they say requirement already satisfied because numpy is already in my system. The same thing with panda. If I want to install panda, they will tell me already satisfied. And the same thing with this notebook. They also tell me that requirement is already satisfied. Okay. So after installing all these packages, once you enter install numpy, just wait for it to install. After that one has installed, look at the instruction, follow the instruction to install it. Do the same thing for all of them. So after you finish installing, you should be able to have your notebook here. So you should be able to have your notebook. Your own might not be in this folder, but just look for Jupyter Notebook. Okay, just look for Jupyter Notebook. You can also open it from your command prompt. It's possible to open it from your command prompt. If notebook is installed in your system, if you type Jupyter Notebook, Jupyter Notebook, and enter, you should be able to open the application. Please look at the spelling. It's Jupyter Notebook. You should be able, once you click Jupyter Notebook, enter, you should be able to open the application. But if it doesn't open, just simply come here, look for it. If you just installed it, so it should be showing at the top of this place, or you can search for Jupyter Notebook. So click on it and open. So once you click on Jupyter Notebook and open, it will open on your browser like this. So it will open on your browser like this. See how this place is? It should open on your browser like this. So it will open like this. I encourage you to have something like Chrome browser in your system. So if you don't have Chrome, try and download Chrome. So once it's open on your Chrome browser, you can come to File and click on New. Again, File, click on this file, click on new, and then open notebook, not console, not terminal, not anything, just open notebook. Okay, so if you open notebook, you should open a new notebook like this for you, and everything is simply working on your browser. So you should open a new notebook for you, and then you should see this, they say select canal. So just simply let's make sure it is Python 3, or you should show any Python version, but it most likely will be Python 3 depending on the Python you install in your system. So just click on this select, and that will be it. Okay, and then the next thing you can do now is to come to file and rename. So rename your file to whatever you want to rename it to, but don't touch the extension, just rename something like Alex, so you should be able to remember the name of your file. I will also show you how to download this file. Okay, so once you do that, this is where you're going to start working. Now before we do anything, I will send you this your project file. I will send you your project file so that you will be able to just simply use it and do this work very fast. So this is your project file. These are your project files. I have about 3 of your project files here. I have this, which was for the statistics, for performing the statistics that I've done. I also have this, which was for your PID controller. Okay, which was the PID controller, the last thing we did. And then I have this, which was the most important one, where we did the optimization and everything. Okay, now we are going to start with this one. I'm going to show you. So the first thing you need to do on this your new file that you've created with Jupyter Notebook is to import those packages that you installed. So we want 2 important packages now. We want hold on, let me check. So like I was saying before the instruction, you need to start importing the packages that you need to actually use. So in Python programming, as well as every other programming language, for you to be able to do certain things, you need to use some libraries that are available for you. In Python, when you want to do analysis, there are 2 very important, depending on the analysis though. But in this your particular project, there is 2 important libraries that we needed. And these libraries were this NumPy library and Panda library that you have already installed. So we have to come to this your file. For you to be able to use it, you need to import. So we now say import NumPy. Okay, so this importing NumPy is telling this package that you want to import NumPy, right? So but we have to do something else. We say import NumPy as MP. Now what this as is, this as simply means alias. So instead of using this long name NumPy, we want to say import NumPy and give the nickname called MP. So anytime we use MP, we are simply referencing NumPy. Okay, I hope you understand that. So after you've done that, you enter, or you can click. If enter doesn't do, you can click play. This is play or run. So if you want to run a particular cell, just click on that particular cell and click run here. So if everything is correct, you should be able to have a different cell. If there's a problem here, if maybe let's assume there was no NumPy or you didn't install NumPy, after clicking this play, there should be a problem here. Maybe you should see some error showing up. But because everything is working fine, you simply enter in another cell. So the next thing we want to import now is Panda. Remember that Panda was the second package that you installed. So we come here and import Panda. Make sure that the name is spelled correctly. So just like we did with NumPy, I want to call Panda PD, right? Once you do that, you can click run. The shortcut for this is shift. The shortcut for running any cell is to enter the cell and click shift enter, it will run that. But if you can't remember that, just simply click on this cell and run. Remember that you must run every cell. Okay, so after entering Panda, we are having an error. They say no module name request. No module name request. Okay, they're telling us that there is no module name request in this particular place because Panda will require requests. Okay, so let's go to our this thing. Let's go to our terminal and install request. So simply go back to that your command prompt, that your command terminal that you opened previously. So just like you installed other stuff now, let us install request. Okay, so to install request is very simple. Just do pip install request. Make sure that your network is connected so that all these things will work. So let's see if our request package will be installed for us. Okay, no matching distribution found. So hold on, let me fix this. I'll come back and tell you how I did that. So let me just pause this. Okay, so the mistake I made here was this is not panda, it's pandas. So I have to say pandas. So I have to put that S. So after putting that and now run, so that should work very well. So if you make that mistake the same way I did, please correct it. So the first thing, we import numpy as p and run. Next thing, we import panda as pd. We import numpy as np, and then we import panda as pd, right? So that works very well. Now the next thing we want to do now is to go look at your project again. Let's see what we did here. So we create a data frame from the given object, from the given data. Remember that you brought two data. One was the temperature, the other one was the roasting time. Okay, so I'm simply going to copy this and then paste it in the new document, and then I will explain. Okay, so I'll copy this, and come to this new place where we are working, and we'll paste this. Now what we are doing here is that we are trying to create a data frame. When we talk about a data frame, we are talking about something like this that you can see here. We are simply talking about like creating a table. Okay, so something like this you're seeing here is like a data frame or something like that. So when you get data and you want to work with that data, you need to create a data frame with it first before you do anything. So to create a data frame, you need to create dictionary, a Python dictionary. You might not understand what a dictionary is because you need to learn Python properly. But the dictionary is, in Python, a dictionary is anything that have something like, it's anything that have a key and a value. Okay, so let's say age. If they say what is your age, you will now say my age is 25. So your age is your key, the age is the key, while the value of your age is 25. So in Python we have something that is called a dictionary. A dictionary is a data type in Python. So we have example of data type is dictionary. So for you to be able to create a data frame, you have to create this dictionary. So we are creating dictionary from two things you brought. We are creating this data frame from two things. The first is the temperature, and the second one is the roasting time. So even if you copy this data like this and paste, if you have new information, if you have new temperature, you can replace all this temperature with that new value. Just make sure that anytime you enter each temperature, you must also enter a comma. So for instance, we have 20, 180, 160, 140, 100, and there is no limit to this temperature. So if you have more temperature, you keep adding them, 60, 560, and so on and so forth. The same thing with your roasting time. So you can also replace this with your roasting time. Okay, you can also replace this with your roasting time. So if you have more roasting time, you can also add, and so on and so forth. Or delete all these ones and add new roasting time, right? So let your data just be exactly the way I create it. You can name this whatever I want to name it, doesn't really matter, right? So now for us to create the data frame, you simply just create a variable. Now in Python, a variable a is simply like simply a location where information is stored in programming. So a variable is simply a location where information is stored. Okay. So we have to create a variable. We can call this variable whatever. I called it df to represent data frame, and then we use pd. We use this pd. Remember that pd represents panda, and then pd has a function called data frame. So this function actually creates data frame from any kind of data you give to it. Okay. So I now say pd dot, because pd is a class or an object or a library, and it has a function called data frame now. So we say pd dot data frame, and then we pass in the data that we want to create data frame from. So once you've done that, you can now click run. Or let me show you an example. So after we do that, we can print out this data frame. Print df. Now print in Python, print is used to produce a result. It's just like I don't know how to explain it for you, but whenever I want to print a result of something, you call print and then put that result. For instance, put that thing you want to print out inside result. So for instance, now this df, we say df is data frame of this data. Okay, we say like df, let me explain again. We say let df be the data frame of this data. So let's print out df. So after doing all of these things, we now say play. So currently we have nothing now. Okay, something is even showing. We have data frame. Okay, so even if you stop for a period of time, data frame will show. So you can see that it creates like a table. It creates like a table for us, starting from the first data, which is the first position, to the last position. You can see, simply create a table to show us that at temperature 220, the roasting time was 16.6, 12.6 rather. At temperature 180, the roasting time was 13.9. This simply try to clarify your data that you brought so that it will be more presentable, right? Okay. So the next thing you want to do is to try and describe those your data. Okay. So let's try and describe. Let me copy this again so that we'll explain what description means. Let me copy this and go back to our file and then paste this. Okay, let me copy that. Let me go back there again. I want to copy this. Copy. Then describe. Okay, so you can do like this. You can say details equals df dot describe, right? And then we print out details. Now remember that we have df here. We have something called df here, and this df simply represents data frame. Now when we have a data frame have some properties. Simply what properties are description of the data that you give. So every data in statistics have mean, median, standard deviation, range, and so on and so forth. Okay, so what this describe method does is that it will be able to bring out the description of a basic description of all of those information that you give or that you supply, or description of the data that you actually supplied. Okay, so once you say details equals to df.describe and print out, let's print out that details and see the information that it will give to us. Okay, so once you print out that subscribe, it can tell you the first information you see here is count. Count is the total number of data that you give. So for temperature, we have 5 number of data. So if you come here and count 1, 2, 3, 4, 5, okay, you also see that. The same thing with roasting time. Now, what was the mean of the temperature, you see it there. What was the mean of the roasting time, you also see it there. What was the STD, like standard deviation of the temperature, you see it there. What was the STD of this, you see it there. What was the mean, you see it there. What was the mean for this, you also see it there. What was the 25 percentiles? If you don't know what is 25th percentile, you can go and check that. What was the 50th percentile? What was the 75 percentile? And also see that. Now, what was the maximum temperature? It was 220. If you look at it, you also see. What was the maximum roasting time? It was 17. Come here, you see it's 17. Okay. So if your data has changed, or if you have new data to change, of course, these details, which is also description of the data is applied, will definitely be different, right? Now, the most important thing so far is this data that we describe here. So the most important thing is this data. Always know that everything we've gotten down here will change if any of this information change. So if you replace this temperature with a new temperature, or replace this roasting time with new roasting time, or replace the both of them with new variables, everything we have here will change, right? So far so good. We have been able to get description of the data that we wanted, or that we used, or that we are using. Now the next thing we want to do now is to also check. We want to import numpy now. It's time for us to do something with numpy. So let's import numpy and do some calculation with it. Or we don't even need to import numpy because we've already imported it down here. We've already imported numpy here, so we don't need to import it again. So let me also copy this code, and then I'll explain what it's doing here. So the first code I want to copy is this guy. I want to copy this guy, and come here and paste it. Oh, that didn't work out. Let me copy it again. Copy. To copy, simply do Ctrl C. When you highlight what you want to copy, simply do Ctrl C, and that will copy for you. Okay. So once you've done that, let me tell you what I'm trying to do now. Now I want to find percentiles of all of this data that I've done. I want to find percentiles. If you don't know what is percentile, I will encourage you to go and read it out and see what is percentile. Remember that this work that we are working is called data analysis. For optimization, we are trying to find the optimal values that your machine can be performing at. Okay, so for us to arrive at that optimal values, we need to completely analyze the data that is coming from your machine. Okay, so what you are doing now is data analysis. After you've analyzed this data, you will now suggest values that are working. Okay, that's good. So if you understand that part, that is very good. So the first thing we want to do is to find the percentiles, and to find percentile is very easy. When you call numpy, remember that this MP simply represents numpy. Now when you call numpy, you call a method in numpy called percentile. You might not be able to remember all of this method yourself. Okay, so the best way you can do it is to use maybe something like ChatGPT or any other AI, and you say something like, how can I find percentiles with numpy? It should be able to tell you, okay, simply call the method called percentile from numpy, and then you'll be able to find out. So once you call percentile for numpy, you pass in the data that you want to find the percentile on. For instance, in this particular place, we want to find the percentiles of all data for roasting, of the roasting time data. Okay, remember that our roasting time was in minutes anyway, so you want to find that. So you simply just pass it the way I've done it here. You don't need to write this thing from beginning. Look at the structure of this, the way I do this. You can simply also come here and represent or replace all of this data with the new data that you have, or add extra data. Okay, so when you do that, you can print percentile like I did. You don't have to bother about this one. This one is just to print out the word. So you can print out this percentile, and then it will print out for you. You see that. So the next thing I wanted to also look is to find the range, right? Now, finding the range is, you know what range is? The range is simply like the biggest and the smallest, difference between the biggest and the smallest and stuff like that. That's what we call, that is what we call range. And then again, we want to also find the interquartile range. That is the difference between the percentile of the roasting time and the percentile of the um what should I, okay, the difference between the biggest percentile of the roasting time and the smallest percentile of the roasting time. So that is what we call the interquartile range. So if you look at our roasting time data, the biggest here was 17 and the smallest here was 12.6. So if you have a new roasting time data, you can simply replace the 17 with the biggest value and replace this 12.6 with the smallest value, right? And then you can print that out. So this IQR is simply a variable that I use to represent this interquartile range, right? So let's print that out again and see what. So again, to print out, simply click on run. And okay, so it tells us that these are the percentile for our roasting time. Okay, these are roasting time. This is the percentile, and then that 4.4 is the range from here. The range between this guy and this guy of the roasting time is 4.4, and of course it's reasonable. Remember I said that range is different between the highest number and the lowest number. So if you minus 12.6 from 17, you should be able to also get this 4.4, which is the range of the data. Now the next number here is the interquartile range. Interquartile range, remember I said, I told you, is the difference between the percentile of the largest number and the percentile of the lowest number, which will give you 0.26. Now you can round this off to whatever you want to round off, it doesn't really matter. Okay, so let's do another thing. So the next thing we did was to find the skew and the Scottish. This is not really necessary. If you want to learn what this is, if you don't understand what skew is or what Scottish is or what kind of data they represent, you can simply just Google it and say what is Scottish or what, and then you should be able to see that. It's not like something really important. Okay, so to do that also, you can simply just type out all of these things. Make sure you type them out completely, or however I want to do that. I will send you this file so that you can simply just copy it. You can simply just copy it. So copy that, and again, remember to copy is Ctrl C. So copy this particular guy. Oops. Okay, I think I did something there that I'm not supposed to do. Mm, oops. I think I did something I'm not supposed to do right now. So okay, so after that, the next thing we want to do is to find our data variance. Okay, um so I'll copy this. Now I will not be able to be explaining what all of this data is because of time, so, or what variance is and stuff like that, because of time. So if you don't know what they are, you can simply just read them off and try to know what variance are and stuff like that. So variance, of course, is another statistical data that is very important, and coefficients of variation and stuff like that. So to find coefficients of variation, you also need to call NP, which is numpy, and call the variation method or function. So when you do that, you simply pass data that you want to analyze. So in our case, we want to pass the roasting time which we've already called in this part. Okay, which we've already called here. So you should know, once we pass that, you should know that we are talking about that roasting time. And then it will also give us the variance. Now coefficient of variation, you can also call, you say mean roasting time equals to mean this, that, pass this. That is to find the mean of the roasting time. Okay, so if you call MP, which is numpy, and call the mean function, and then pass data that you want to find the roasting time. This thing is simply the same thing as saying, like, if you have like four numbers, say 2, 3, 2, 4, 6, 7. Okay, so now in this case, the mean will simply be the sum of this number, right, divide by 4. That will give you the mean. But instead of doing all of those things, you can simply say MP. You can simply say mean now equals to NP dot mean, right? And you pass in 2, 4, 5, 6. Now if you do like something like print mean, you should simply bring out the result of these 2, 4, 3, 6 for you, which is the mean, right? So that is all we want to do. So in this case, we are simply saying that what is the mean of the roasting time? So we simply say MP, and then we pass in this roasting time data. This roasting time data here that you're seeing, this thing you're seeing here, is simply referencing this particular guy. So if you pass in data bracket temperature, it will use this information data here. If you pass in data that roasting time, it will use this information data here, right? So we say roasting time, so it will simply go and use the value of roasting time, and then we print out this variable here. Okay, and then the next one we want to see is the coefficient of the roasting time. I think I should simply change it. There's a mistake here, so this guy should be for here, and then for this guy we should call that mean of roasting time. Okay, if you want to be able to write text like this, remember to always put hash. If you put hash and write text, the machine will not read it. It will know that it's text. Okay, and then every other thing will be read by the machine. Okay, so now this one, the down one, is coefficient of the roasting time. Okay, so coefficient of roasting time is simply standard deviation over the mean times 100. That is what coefficient means. You find the standard deviation. If you want to find the coefficient of variation, you find the standard deviation of that data divided by the mean of that data multiplied by 100. That will give you the coefficient of variation. So in NumPy, there is a function called std, which simply return the standard deviation for you. So when we call this function, it will return the standard deviation of the roasting time. Why this guy mean roasting time, we got it from here. It's a result of this particular guy. So whatever we got now, we now multiply it by 100, and then we'll print it out. If we run this now, it will give us the answer. Okay, so we got the standard variance here, which was gotten from this particular guy, which is 2.14. And then we got the mean roasting time from this guy, which is 14.7. And then we got the coefficient of variation, which is 9.94. So coefficient of variation, like I said, is simply a standard deviation divided by the roasting time multiplied by 100. Okay, that will give you this particular variable here. Okay, so what else? The next thing now is for us to plot our graph, to plot this first graph that appears here. Okay, so to plot this graph, we need something called matplotlio. I think this matplotlio actually comes with your notebook. Okay, it actually comes with your notebook. But if you don't have it, you can simply go and say, go to your browser and say how to install Matfolio. You can simply come and say how to install Matfolio in Python. Then you see tutorials on how to do that. So you can see here, pip install Matfolio. Okay, because I'm sure you might not have it. So let's add it as some of the things you will install. Okay, so let's add it. So the next thing you should install, because you need to be able to plot that graph, is Matfolio. So, matplotlib. So that is the next thing you need to install. Okay. So you can simply go to your terminal. You can simply copy this command. And come to your terminal and run it. So if you come here and run install matplotlib, I say matplotlib. You come here and do that. So the command should be able to run. I think I already have mine. So if I have mine, there will be no need. You tell me the requirements already satisfied. So if you don't have yours, that will install that for you. So when it installed that for you, we want to be able to use it and plot our graph and plot this graph. And this graph will be graph of roasting time over what? Frequency, right? Roasting time over frequency. So let's just see how we want to do that. So you can copy this command rather, or write it out. And simply do this. Oops. This guy, my antivirus is causing issue. Anyway, so as you can see, I tried to install matplot library and they tell me that my requirement is already satisfied. That is simply because I already have the library in my machine. To your own, if you don't have it, to not tell you this story. So to simply import it for you. Just follow the instruction that are showing on the screen after you run this command. Then you should be able to do that. So after you do that, let's copy this command and I will explain all of them for you. Let's copy this and come here. So I'm pasting it in this new cell. Now this first line here imports matplots library as PLT. Okay, so just like we import numpy and all those one, we want to import that library that we just installed now. Okay, in this place as PLT. So anytime we call PLT, we are simply saying that it will represent matplot library. Okay, now the first command we want to enter is what kind of graph do we want to plot. So it has different graphs. Matplot library has different graphs that you want to plot. Maybe you want to plot something like histogram or stuff like that. So you can look at that by yourself or at your free time. But the one I wanted to plot in this particular one is histogram. That is why I use this plot.hist. So HIST here simply represents histogram. It's a short form of histogram. Okay. So after that, I now put data that I want to plot, which is the roasting time, and then bin size is 10 and edge color is black. Now let me show you what is bin size. Bin size is simply the distance, the width. Okay, simply the width. That is what it means. All right. Okay, so it's simply the width, and then the edge color is that edge of that histogram itself. Now x label, plot.x label say what should be the label of the x side. Plus.y label means what should be the label of the y side. So let me show you again. this is x, so roasting time in minutes, y this should be the y-axis, which is frequency, right? So if you go back there, you can change all of those things. Now roasting time title is this title of the histogram, which is what will show on top. Okay, and then this final command is to show. So you can do all of these things, but if you don't call show, the histogram itself will not show, right? So let's plot this again. Let's run this. If you run this, it will take a little time, but it will show up what you want. So let's wait and see. Take a little time. Okay, now after taking a little time, it brings us our graph. Okay, brings us our graph. So remember, you first import it and then pass in the data that you want to plot the graph for. In this case, we simply want to plot the graph for roasting time, and then put all this information that are not really necessary. Now, if I want to also plot the graph for our temperature, I can do the same thing. I can simply copy this guy in again and come to a new cell down here. So instead of plotting for our roasting time, now I want to plot for temperature. So I'll come here. Our temperature was called this guy, so that I will not make any mistake. So let me copy this and I'll show you what to do right now. Remember that the previous one here is for roasting time, right? So I want to now plot for our temperature, right? So that is, I replace that roasting time with the name of the temperature, the name of the variable or the key that represents our temperature data. Now I want to call the x-axis. The x-axis now should be temperature. And remember that temperature is not in minutes, temperature is in degrees Celsius now. So let me copy degrees Celsius here. It and paste it, right? And then this one should still be frequency. So this one should be temperature distribution. The title now, I want to call it title temperature distribution. Okay. And then after I've put my x label, put my y label, put my title, I will now call this function called plot. Now I don't really need to do this anymore. I don't need to do this anymore. The reason why I don't need to use this import anymore is because once you import a package or a library, it will be available for you everywhere. So I've already imported here, so it should be available for me everywhere. So let me simply run this cell and see what it will give us. Of course, now we have our own. This is for roasting time and this is for temperature distribution. Okay, so it tells us how the temperature distribution works. Now all of these things, like we are simply trying to clean our data to make it more clearer. So if somebody looks at it, somebody will say, okay, this is what this data means, and so on and so forth. Okay, the next thing we did again was let's see, was to calculate the coloration. Okay, coloration simply means the relationship between two variables. So the coloration between temperature and roasting time. Okay, that is what coloration simply means. Now to calculate this coloration, we simply use data frame of temperature and data frame of the roasting time. So let me copy this and paste so that you understand. Let me copy this and paste so that you understand what I'm talking about. So I copy this and I paste now. Now the main way to calculate coloration is this guy here. So coloration is simply the df of temperature dot the coloration of roasting time. Remember what df means. Remember from the above, from the what we've done so far, df simply means data frame. Okay, data frame. So data frame of data dot, data frame of temperature dot, data frame of roasting time will give us the relationship between these two information, right? So once you do that and you run, once you do that you run, it will print out correlation between temperature and roasting time. It gives you this variable as relationship between these two guys. Okay. So these two guys we are related in a negative way. That is 0.997. Okay. You can check what does negative correlation means. Let me show you what to do now. So if you don't know what correlation means, you can simply go here and say what does negative correlation, what does negative correlation means, right? You can see there are already stuff here that explain what it means. Negative correlation is a relationship between two variables. Negative correlation is a relationship between two variables in which one variable increases as the other decreases and vice versa. So what it simply means is that since our correlation here is negative, it simply means that when one of our our data was increasing, the other one was decreasing, or when the other one was decreasing, the other one was increasing. Okay, if you look at our temperature data, you should be able to understand that when our temperature was at 220, the roasting time was small, right? When it was at 100, the roasting time was high. So it simply means that as our roasting time or as our temperature increases, our roasting time decreases. Okay, so that is what that negative correlation simply means. If you want to also find what positive correlation means, you can also go and Google what positive correlation means. These things are not really complicated. You should be able to know that. Okay, now to actually show how this correlation works, that is to show the relationship between these two variables, we need to plot a graph to show how these two variables relate. Okay, that was this graph that shows here. That was this graph here. So this graph was actually showing the relationship between this particular guy and this particular guy, the relationship between temperature and roasting time. Okay, so I copy this again because this is the graph detail that we use. I just do that. I think I just did something I'm not supposed to do. Okay, let me see if I can return it back. Oh, just deleted something very important. Hold on. So, sorry, before I went on a little break, the next thing we needed to do now is to simply, like I said, print out the relationship, the graph that shows the relationship between the roasting time and the temperature, right? So remember that we've seen that the relationship between these guys are negative. So we wanted to show it as a graph and see how they relate. So this is the what should I call it? The code that you can use and do that, right? So copy this code again and come to this our own new file, paste it. Let me explain. So the first line of our code here, simply return the correlation again. Like this thing we did here, simply returns back. We don't necessarily have to do that, but we are just doing it so that for clear. I'm just doing it for clarity. And then this third line here, print out this same thing again. Anyway, we can simply delete this since it's not even necessary. We can delete that particular line. We can just delete that particular line. Okay. And since we want to plot the graph that shows the relationship, remember that in cell 11 we found the relationship, right? Now in cell 12 we want to be able to plot the graph. Now instead of using histogram this time, we want to use figure. There's no really good reasons why we need to use figure. We are just trying to use a different graphical representation to show it. Okay, now we want to scatter the data around so that to show the relationship, so we use plot scatter. All of these things will look very complex for you since you've not learned these things yourself, but just know that this figure simply represent the kind of plot dot figure represent the kind of um, data representation we want to use. We can say plot dot histogram, that we use histogram. We can use plot dot pie, that we can use pie chart. But for figure, we need to use different type. Okay. And then what do we want to do with the information? We want to use the relationship that exists between these two information and scatter it around. So we use this function called scatter. And then again, the x label will be the temperature, the y label will be the roasting time, right? So any information you enter first here will be the one that will be on the x label. The data that comes next here will be the one that will be on the y label. So we want the color to be blue. You can simply change it to R so that it to be red. And we want to label the all these things data points. Okay. And the title should be roasting time versus temperature. Then plot.grid, should we show grid lines? You can set that true. When we say grid lines, you are simply talking about these lines that are showing here, right? These lines. If you set that to false, it will not show. So we want to show that. And then finally plot.show, so that our plot will show when we do that. And then let's run this. So as you can see, it returns back all of these things for us. Okay. If I want to change back, if I want to remove this grid line, I can change this to false. I can change that to false. If I want to change the color of this to a different one, maybe blue, I can come here and change this arrow to B. B to be blue. And then if I run that cell again, it should give us no grid line, but just scattered plots. But I want our grid line to always show. So our grid line should show. So I reverse back and plot again. So this time around, our grid line is showing. I might still want the color to be blue, the scattered plot color to be blue. So I'll return this line back to blue. So now we are having this particular guy that is showing here, right? Okay. So what's the next thing we want to do? I'm really getting very tired now. Very, very tired. So the next thing we want to do is to do regression. Okay. Now, what do we use regression analysis to do? Why do we want to do regression analysis? If you come here and ask importance of regression analysis, importance of regression analysis, to tell you why you need to do regression analysis. So regression analysis can help identify which independent variables significantly impact a dependent variable. For example, it can determine which marketing channel or advertising strategy influence sales most. So the importance of regression analysis to our data is that we want to be able to check which data influences the roasting time most. Remember that our job is to actually do optimization. So we want to find like which particular temperature or which particular this particular temperature or whatever actually influence our data the most, right? So to be able to do this particular guy, you need to use something called linear model. This is very complicated. You don't even need to do this. I just added it to your project because I felt like you needed it, but this is very, very complicated. Okay, so you just need to just do it if you want. So I've already installed this model. I don't know if it's in your system. I'm wondering if it is in this thing. if it is in your package. But if it is not, if you have any problem when you run this command, just let me know so that I will tell you how to install it. So I will copy this again and come here, because that is the function, or that is the library that we will use for regression model. So copy this and run. For me, I have no problem because it's there. But if you run this line of code and you have a problem, just let me know so that I'll be able to tell you how to install it. Okay. So after doing that, we can simply start doing our regression analysis. Okay. Let me simply copy this code, this block in line 41 here. Let me copy that and paste, and then I will explain it for you. So explain it. Let me copy this and paste. So after importing, so we say from linear model import linear regression. So this linear regression is a function that we are going to use to perform our linear analysis, our linear regression analysis, and it is from this library called linear model, skidlearn linear model. Okay. Now we need to preempt our data. For us to be able to do that, we need to reshape our data into various ways. Guy, explaining what reshaping means is another different thing. But just essentially, just whenever you want to reshape the data, just use this way that I did. Okay, put the data in a data frame and then reshape it to whatever you want to reshape to. Okay, and after that, call the linear function that we imported. So this model, we assign the linear function to a model or to a variable. Remember I said that the variable is what we use to store particular information. So in this instance, we are saying that the linear function should be stored in a variable called model, right? And then we want to fit that model into a particular graph. Okay, so we put it into x and y graph. And then we get the coefficients of everything. Guy, this particular place is complicated, right? Very complicated. If you get to this particular place, just copy this code like this and paste. Copy it like this and what paste to run. Okay, you don't even need to change anything. If you follow the way we've been doing, you don't even need to change anything in this particular place. You just copy it and paste, and then it should run for you. If you run that, you should see that the linear equation for this particular guy is this. This linear equation is what you use to see. Anyway, let me explain what linear equation is for you. So let's just come here and say, what is linear equation? What is linear regression equation? What is linear regression equation? So that you understand, a linear equation has so let me see if I'll see a perfect explanation for you. So linear regression equation explained. Let's see that. Let's read that and see. Okay. A linear regression equation describes the relationship between independent variables and a dependent variable. It can also be predicted. It can also predict values of dv, that is dependent variable for independent variables you specify. So this equation that we created here, your lecturer should be able to understand it better. It's simply showing the relationship between dependent variable and independent variable. Okay, with this equation here, we should be able to solve for whatever I want to solve. That is just that for that particular one. So after that, we need to, the next thing we might want to do now, which is like the last thing for this particular guy, is after we found our linear regression equation, we want to use that linear equation to actually solve for the scattered plot. Okay, since we've been able to achieve our linear regression equation, we want to be able to use that to actually solve for our scattered plot. Now, let me copy this again and paste in our new file so that you will see that. Now I hope you're seeing that this thing is really tougher than the way you think. So the way you are telling me that do that, it's not easy like that. It's not easy like that. Okay. So now I want to create scattered plot for our using our linear equation. So what you do here is simply do exactly what I've done. If you look at, the only thing you need to change in this particular place is this part. This is the data for your temperature. So if your temperature have changed, replace it. This one now is data for your roasting time. If your roasting time have changed, replace it. Now if you've been doing all of this, look at this guy now. This particular guy represents this our linear regression. So if your linear regression is different, if this value is different, put the new value here. If this value is different, put the new value here. But you can maintain exactly what I've done here. Now look at this place again. You can see that the maximum temperature is 220, which is what we got here. So if your maximum temperature have changed, please also replace that here. Okay, replace that here. That is just that for everything. So follow the same way that we've done. Now first we want to plot. The other one was histogram, the other one was figure. For this one it will be plotting, just like when you use a graph sheet to actually plot. That is what we want to do now. So the X label should be our temperature, the Y label should be roasting time, and our title of the graph will be roasting time versus temperature with regression line. Okay, so the regression line that we are going to get will be obtained from this our regression equation. Okay, that is the most important reason. The reason why we did our regression analysis was to be able to obtain the line, regression line, right? That is simply what we want to do that. So this formula will be used to replace our regression line, right? So after doing that, plot grid, should grid show yes, should legend show yes, and plot dot show to actually run it. Okay, so if we run this now, if we run this, should show all of this, should show all of this. Okay, this is our legend, this is our plot and stuff. Using our regression line, we show how our regression line actually works. Okay, so if you follow all of this instruction from beginning, you should be able to come to this particular place. Now looking at this particular scattered plot now, you might begin to imagine what was the best roasting time, or what was the temperature that gave us the best roasting time. Of course, our values are actually out of point here, right? It was actually out of point. That was based on data we got from our experiment. But it doesn't really matter. In this particular one, you can find the closest time to this particular regression line. You can see that the closest temperature was around 140. That is, the closest temperature to this regression line was 140. Okay, so you can take that as your optimum, maybe optimum temperature, because it is the closest to this particular guy. And you can see that at our optimum temperature, your roasting time should be around 15, right? Should be around 15 and above, between 15 and 16. Okay, this was our closest line, our closest temperature to this particular guy. Okay, and it should give you this particular guy, this roasting time of the optimum. So that has helped us to actually be able to do something reasonable. Okay, all right, so that is that for that. This video is already very long. The other statistics stuff you can do, but those ones are miscellaneous. They are not really necessary. Not really necessary. I simply picked all those things. So this guy was the most important guy that we did. Okay, so if you have any question so far, please let me know and I'll be able to answer them. Now after this, after you've done this, next thing you want to do might be to save this your particular work, okay, or to download it. So you can come to this file and you can do save as. You can do save as. So you can do this and save. I think there's a way you can save this as something else. Okay, come to download. Come to download. Let's see if this will download for us. Okay, so once you do download, to download that particular file for you. There is a different way I also did this. There's a way I downloaded this like as Anyway, you can take this to the computer village and they will print it out for you. But there's a way I downloaded this. I think I've forgotten. My head is choked up. Choked up, choked up, choked up. Okay, save and export. Yes, so save and export as PDF. You can do that as PDF. Save and export as PDF. I don't know which English they will tell me now, but that should be able to help you export this stuff as PDF. Oh, I'm able to do that. Anyway, if you do download, if you do this as download, if you do as save as or whatever, and then you save as and it comes into your document here. If you go to your download, if you go to download, you should see that. If you go to download, you should see that. The way you want to convert, if you want to convert this particular document to PDF now, you can simply go online and say how to convert IPYNP to PDF, and you see website that will help you do that. Okay, so but I'm going to send you this particular file now. With this file, you can also open it in your own notebook. You can open it in your notebook and edit whatever I've been doing. Good. Hope you understand. So if you open it, it will show exactly the way you want, so that you can copy, do whatever you want to do, and all the rest. Right? If there is any part of the video you don't understand, so this video is already more than 1 hour plus. Hopefully you are able to get some kind of stuff. But just go through it, whatever, let me know, and we'll talk about it. Okay, that is that for now. See you.